Hello and welcome to this video on equations of circles. Uh, for my classes, this is 10.6 out of the textbook, but we're going to talk about the center of the circle, the radius of the circle, how that all fits together as an equation using Pythagorean theorem, and then we're going to just go back and forth between drawing circles and then writing the equation of circles. I will also use the TI-Nspire to show you how to graph circles and find intersection points on the TI-Nspire. It has special tools and features that we can use on that as well. And we're also going to solve simultaneous equations on the TI-Nspire as well. So there's a lot in this video. So hopefully you'll follow along. Okay, so the first thing you're looking at here is the proof, or kind of the showing you how the formula for the equation of a circle works. It's all based on the Pythagorean theorem. You can see that we have the center of the circle at HK, and right there, right? And we have this variable point, xy. This xy is supposed to represent any point around the circle. It doesn't matter where it is. You have some general xy. So this works for all x's and all y's. Hence, you get an equation, right? You get an equation that has x and y in it. Now, h and k, those are going to be constants. They are going to be a number that are not variables. They don't change. The r, the radius of the circle, which you can see here, that's going to be a constant as well. That's a number that's not going to change. But the x and the y, those are variables. Just like when you have a linear equation, you have, your x and your y, and you plot an infinite number of points to make a line. Well, we're going to do the same thing. We're going to plot an infinite number of points to make a circle. But how do those points relate to each other? Well, it's just Pythagorean theorem. So if you make yourself a right triangle, you can see that this distance on the bottom, if you look at the x values, this distance on the bottom is x minus h, from the x here and the h here. So you just subtract those to get the distance on the bottom of that triangle. Do the same thing with the y's. This distance on the right side of the triangle is y minus k. Y minus k, right? The y value here minus this y value here will give you the distance or the height of that triangle. So what's left? Pythagorean theorem. You just take the x minus h, put it in here and square it. So x minus h squared. You take your y minus k, put it in Pythagorean theorem and square it. So you get the one leg squared plus another leg squared equals the hypotenuse, and in this case the radius, squared. So there it is. That's the equation of a circle. It just comes from Pythagorean theorem and the relationship between the center and all the possible points on your circle, which is xy. So this is the equation we're going to be using. Right? It's got the center and the radius. You're going to notice a couple things that are really important. One is that these are subtraction. They're minus signs. They're subtraction. They are not addition. When you did the length of the sides, we had to subtract from our points. So these are always negatives. So let's say your center was had a negative number in it. Like, for example, if this was -2, then in your equation, you're going to have x minus a -2, which is going to give you x plus 2 for that part of it, right? So we got to be careful about that when we're doing equations. And then also the radius. This is the radius squared because it's Pythagorean theorem. So if your radius just happened to be 5, then this isn't 5, it's 5 squared, which is 25. So we just got to be careful about those things. But that's the equation. Let's get to work. So the first one says center is -2, 2. So I'm just going to draw this out. -2, 2 is my center. And I have a radius of 3. So I'm just going to go 3 in every direction. This is probably the easiest way to do it, is just go up, down, left, and right, 3. Because then I can get on even points, right? If I tried to go this way 3, it's hard to tell where you would end up at. But once you get that, then you just want to draw some tangents to these kind of sides and try to fill in the best circle you can. Doesn't have to be perfect, but it should look round. It shouldn't look like a square or a rectangle or something, or a polygon. I have some people do things like, let me draw it incorrectly. Some people do it like, oh, like this, right? And you're like, wait a minute, that's not a circle, right? So don't do it like that, but it doesn't have to be perfect either. Erase that for you so you don't think that's something good. All right. Set it there. So that's it. You just draw the circle. Now, what's the equation? I didn't have to draw it to get the equation. I can get the equation just from the information up above, but we're practicing both. So it's x minus your x value of your center. So that's a -2, just like I was talking about before. Y, now it is plus in between because it's Pythagorean theorem, remember. But we have y minus, now this time it's a +2 squared. And then I have the radius squared. Remember, it's Pythagorean theorem. Keep that in mind. X squared plus y squared equals hypotenuse squared. All right, so I could put this together here and just say x plus 2 squared, which I'll have you guys do on a normal basis. Okay, and then we're done. Got another one, center at 3, -1, right there. And radius of 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, oops, going way down here. Can I move this? There we go. 1, 2, 3, 4, 1, 2, 3, 4, and then do your best to draw your circle. That's not very good, but it's okay. All right, then we need the equation. X minus 3 squared, just that number, plus y minus the y squared. So y minus a negative is y plus 1 squared. And then the radius squared, 16. You can leave it as 4 squared if you want. You can write it as 16. Either way is fine. Okay, now they're giving us a couple points now. They're not really giving us the radius. So the radius is something we have to find on our own on this problem. So the center of the circle is 0, 5, 0, 1, 2, 3, 4, 5. And the point on the circle, 2, 3. So this is just some point on the circle. So I know my circle is going to do something like this. Something like that, right? That's what my circle is going to do. It's not a very good one, because you got to keep the radius the same all the way around, right? Switch colors a little bit here. So what we need is the radius. So I have these 2 points. Well, the radius is just the length of the between those 2 points, the distance. So I just do a quick distance, right? Do a little right triangle. This is 2 on that side. This is 2 on that side. So I know this is 2 root 2. It's actually a special right triangle, 45, 45, 90, isn't it? So that's a quick shortcut. So 2 root 2, that's my radius. So I can write the equation of my circle. I'll just do it down here. Now this time I have the center. Remember, you're always using the center. You're not using a point on the circle. You're using the center. So this is x minus 0 now. I don't need to write the 0. I can just write x squared, but I'll write it for now, and then I'm going to simplify it. And minus 5 squared equals, now we got to use our 2 root 2 squared, and you got to square the whole thing. And let's just simplify this. X squared plus y minus 5 squared equals 2 root 2 squared is 4 times 2 is 8. So that's the simplified version, and that's what I would go with. Okay, graphing now. Now we are given the equation, we're going backwards. We're just going to graph. What do you need to graph? You need the center, you need the radius. So the center is always going to be the opposite of these numbers. Remember, it was subtraction in the middle here, right? This subtraction was already there. So this 1 is actually a positive 1. It's not a negative 1. But in this case, this is a positive, but it used to be negative when I did the whole Pythagorean theorem in the beginning. I'm just going to go back real quick just so I can remind you. Remember these right up in here? These are negatives because we were subtracting when we did our Pythagorean theorem. So that positive is really minus a negative. So my center is actually at -2. That's a real common error. So make sure you really pay close attention to that. Now the radius, it's not 4. It's this, remember, this is always 2 squared from the Pythagorean theorem. So the radius is just 2. Now I can graph it. 1, -2 is my center, and a radius of 2 in all directions. And shazam, there we go. Now this one's just taking it a little step further and saying, let's graph this out for practice. So let me do that first. This center of this equation right here is -1 and +2. Radius is 3. It goes pretty quick when you get used to it. -1, 2 is my center. Radius of 3. And there's my circle. That's a horrible circle. Anyway, we'll go with it though. But the thing is, I'm checking to see if this 2, 0 is in the circle or outside the circle or on the circle, right? We don't know. Just by eyeballing it, you feel like, oh, let me look. Okay, so 2, 0 is here, which looks like it's on the outside of the circle, but I drew my circle really poorly, didn't I? Let me try to redo this drawing and see if things change a little bit. So this was a radius of 3. Actually, I can tell that it's going to be outside, but if I drew my circle correctly, then we might be wondering, like it might be close, right? We might wonder, like, is that inside, outside, or right on? I'm not sure. So this side, I can tell it's on the outside. We can just look at it, but you need to know how to do it algebraically. So what do? Well, it's kind of like when we were doing the checking the Pythagorean theorem to see if we had an obtuse angle or an acute angle. It's kind of like that. We're going to put in the point into our equation. So I'm going to take our equation, put 2 in for x, put 0 in for y, and then I'm going to ask myself, is that equal to 9? Is it bigger than 9? Is it less than 9? So this is 3 squared, which is 9. I've already got more than 9 already. -2 squared is 4, so that's 13. Yeah, 13 is bigger than 9. So if this is bigger, then that means your point is outside the circle. If this number on the left happened to be less than 9, your point would have been in the circle. And if it would have been equal to 9, it would have been right on the circle. So that's just a check that you can do real quick. Sometimes if it's really close, you need to do it algebraically. Plus, we want you to do it algebraically anyway. All right, here's a different look at some of the stuff you can do with circles and the equations of circles. So now we want the equation of a line. This just goes back to it's kind of a side little problem, really. It's just getting us to remember that the radius of a circle is perpendicular to the tangent line. So if I draw this radius in going to this tangent point, I know that that's going to be a 90-degree angle. And so when I start thinking about how do I draw the equation of a line, AB, I know I need the slope, right? If you're going to do the equation of a line, you need slope, and you need a point that you can use. Well, I have a point, I just don't have a slope. So how am I going to get that slope when I don't know what B is, right? I don't know what that is. Well, I don't need it because I can figure out the slope of AC instead. So let me do that over here. Slope of AC, 5 minus 2 on top, y minus y, and then we have x minus x, 2 minus 1 on the bottom. So that's 3 over 1, which is a slope of 3. Now I know that AB is perpendicular to it, so the slope of AB is going to be the negative reciprocal of that. So it's going to be -1/3. That's the slope of this line. Great, so I've got a slope, I've got a point. You could use point-slope form, or I'm just going to go ahead and use slope-intercept form and just find my intercept. So I'll put in the 0.25. Whoops. And then simplify that. So that's -2/3. Add it over here. We got 15/3 plus 2/3. So 17/3 is my y-intercept. 17/3. So down here I'll write the final equation. There it is. That would be the equation of the tangent line. It's just a side little problem. Doesn't really use the equation of the circle too much, but it's just a little problem that kind of additional thing. So I think, yeah, so let's look at the calculator now. So you're going to need your TI-Nspire. So if you want to pause your video and then get the TI-Nspire fired up, we're going to graph these two equations out on the TI-Nspire. And it's going to look something like this, but I'll start fresh for you. So get your TI-Nspire, open up a new computer page size. I don't really like the handheld, it's too small. So computer page size would be good. Or you can use your handheld, that's fine. It's a little easier on the laptop though. And then we are going to add a graphs page in. Okay, I'm assuming that you've got it all loaded up and ready to go, so I'm going to continue. Okay, so we're looking to graph these two equations. In order to do that, I'm going to change this to circle. Like it would be difficult. Like if you look at these, the y value is in the equation, so it's kind of hard to graph that. If I wanted to, I could solve for y and have like a plus and minus equation, and I could do that for both of them. And I could graph the top half and graph the bottom half separately as two kind of parabolas looking things, right? The top half and the bottom half, and graph them. So I'd get like 4 graphs, right? That's the old school way. You could do it that way, but our TI-Nspires have this cool feature to graph circles. So I'm going to go into Tools. I'm going to go to right here. It says Graph Entry, like Edit and stuff. They have like different function. Function is the normal one we're using. So if you ever want to go back, you can go to Function and go back. But right here you have a bunch of equations and templates. So you have a parabola and ellipses and hyperbolas and all these conics. But we do have circles. And it gives us 2 forms there. The one at the top we're going to use. The one at the bottom they call standard form. But we're just going to use this radius and circle form here, right? Okay, so just hit that, and you'll see up top here it gives you the equation of the circle already. You just have to plug in the numbers that you want. So the first one is, remember the negatives and positives. You got to keep that straight. So this is actually a +1 and a -2 with the radius of 4. +1, -2, radius of 4. So, oops, messed it up already. +1, -2, and a radius of 4. And you hit enter and it'll graph that out. And of course you can move this around, whatever. So +1, -2, radius of 4. +1, -2, radius of 4. Great. Now if you want to graph another circle, on your calculator you can hit the tab button and the equation bar will come up again, right? Just hit the tab button. Okay, this one I want a -2, +5, and a radius of 5. -2, 5, 5. -2, +5, +5. Hit enter. Oh, I got another circle. Great. Now we're going to actually find the intersections of these circles. So basically the solutions of the system, if we want it. But before we do that, let me just show you a couple things about the window. If for some reason you had you had really big circles and it was really hard to see your circles, in order to zoom in or zoom out, you can do a couple things. You can either just grab the axis here with your hand and just move it and just keep going as far in or far out as you want. That's probably the easiest way. Then you can look at it however you want to look at it. You can also grab the screen and just move the screen around where you want, so that'll be helpful. And if you wanted, you could zoom in using the window tool over here, the window settings, right? You could do that. Maybe good, but you got to be careful. One thing about the circles and the TI-Nspire, like let's say I just wanted to change one axis. Like when I grabbed this axis before, it moved both axes at the same time. Let's say I wanted to move one axis. Well, if I hold the shift key down, so you hold the shift key down and hold it, and then grab one of the axes and move it, you'll see that only one of the axes changes and the other one stays the same. Well, for circles, well, and in fact, for any equation in any graph, it's going to squash it, right? So this isn't going to look like a circle anymore because I changed one of my axes. And you might think, well, what's wrong? I didn't get a circle. Well, the problem was that you just changed one axis instead of both. And when you change your window settings, that might happen to you. So it might be better if you just grab the axis and move them both at the same time. It's probably a little easier. It's quicker, it's easier, and you won't be morphing your graph around at all. Okay, so we're going to look for these intersections. This right here where the red one touches the blue one, and that intersection where the red one touches the blue one. So let's do it. So you go to your tools, you go to Analyze, and there is a tool called Intersection Tool. So when you click on it, you'll see at the bottom down here, at the bottom left corner, it says, what's your first corner? And it gives you this little X that you're going to use. Really what you're just doing is drawing in a box. So I'm going to click and then drag. And when you have that intersection point covered, like the intersection point actually should show up. You can see it there. So I'm going to click and just enclose that intersection. And there's my intersection point, negative 2.45 and 0.02. Let's do it again for the other intersection. Analyze graph, intersection, and just come over to the left somewhere. It doesn't really matter where. You just want to enclose that intersection. The only thing you don't want to do is make it so big that if I were to do it, it would intersect both my intersections at once. Sometimes that messes things up. In this case, it looks like it's working, but so I'm just going to click. There's my other intersection, 1.92, 1.89. So I found my two intersections graphically. That's how to do them on a graph. All right, if you needed those. Let's do it algebraically. So I'm going to insert a calculator page and go to my tools and go to algebra. And there's this thing called solve a system of equations. Solve system of equations. Aha, let's use that. Very powerful. Useful tool. I have two variables, x and y. And I'm using these equations right here. So I actually have to just type those equations in just as they are. X minus 1 squared plus y plus 2 squared. Don't forget your pluses and minuses. Be careful that you arrow over. Don't leave any spaces though, no spaces. Just type it in just like you see it with no spaces. I'm using the caret for the power. If you don't know that yet. Oops, this is minus 5 squared. X plus 2 minus 5. And then arrow over to get down again. And there's my two equations. Let me double check them before I hit enter. Looks like they are good. Okay, so I'm going to hit enter. And you'll see that I get these really funky things. I don't like all those square roots and stuff. Actually, what happened is they did the quadratic formula and all this stuff. But I want a decimal. Well, we should have learned by now that if you put a decimal in your equations, you'll get a decimal out for your solutions. So I'm going to just put a decimal right after this 6. Doesn't matter where you put it. Just put a decimal in there somewhere. And when you hit it, then you'll get your answers out of here. Now you'll see I get two pairs. I have an XY pair here, negative 2.45 and 0.02. Well, isn't that this one right here? Oh yeah, negative 2.45 and 0.02 right there. And then I will get another set right here. You can see it says or. So or this, where I get 1.92 and 1.89. Here it is, 1.92 and 1.89. There it is. So this is just two different ways to get the intersection. You can use the solve tool, this solve a system, or you can use the intersection. Okay, those are just, I mean, that's not going to come up a lot, but it's a really cool thing, and it's something you should be able to do. The main point, of course, is just going back and forth between the equation of a circle and the graph, like being able to you find the center or find the radius or vice versa, write the equation if you know the center, know the radius, that kind of thing. There is a challenge problem that's in the notes. You'll see the link to it. It's in the Google Doc or in the Google folder, so you can find this if you're up for a challenge. This is actually the proof of the law of cosines. It's very, very cool. I picked this up at a conference for a math competition. Very, very cool. Check it out. If you're up for a challenge, the answers are at the bottom of the thing. So try it on your own first, and then you can check out the solution method and see if you can get close. But it uses circle geometry, and you come up with the law of cosines, which is really cool. Algebra 2 topic, right? Anyway, let me know if you got questions.